Hi there students, this is chapter 2 of chemistry, the structure of the atom. Now this is a very important chapter because it lays in the foundation of chemistry. A very logical chapter, we're going to go over this step by step, so bear with me. The first thing we're going to cover is the definition of matter. Now matter is anything that occupies space and has mass. Matter is also something that can be perceived by the senses, something that you can see, touch or smell is matter. Now, matter is divided into both elements and compounds, but a lot of students don't know the difference between an element and a compound. There are also terms such as an atom, a molecule, and an ion. What do these all mean? Well, let me break it down for you students. Matter is divided into elements and compounds. Elements are what you see in your periodic table. So when you look at your periodic table, everything from hydrogen, nitrogen, sodium, magnesium, these are all elements. A compound is a combination of two or more elements. So imagine I have hydrogen and I have water. They combine together, hydrogen and oxygen, sorry. They combine together and they form water, two different elements. This is a compound. Now, what is the difference between an atom and a molecule? An atom is just one element by itself. So, for example, um, lithium metal, sodium metal, carbon, what else can I think of? Aluminum metal. Whereas a molecule is just one element but present in 2, 3, or 4 numbers. It's mostly in the case of gases. So take oxygen for example. Why is it represented as O2? Because you have two oxygen atoms coming together to form a molecule. The same thing with hydrogen gas. Two hydrogen atoms form one hydrogen molecule. Two nitrogen atoms form one nitrogen molecule. You also have molecules made up of different elements such as carbon dioxide. So you've got one atom of carbon and you've got one molecule of oxygen which comprises of two atoms of oxygen coming together to form one molecule of carbon dioxide. The same thing with ammonia, NH3. Ammonia comprises of one element of nitrogen, or one atom of nitrogen, sorry, three atoms of hydrogen coming together to form one molecule of ammonia. Now, an ion, on the other hand, is a positive or a negatively charged particle. For example, sodium is represented as Na plus, as a sodium ion. Chloride ion is represented as Cl minus. Aluminium ion is represented as Al3 plus. But why these numbers, students? Don't worry about that part. We'll come to that in subsequent chapters. The kinetic theory of matter, very important. Kinetic theory of matter basically deals with energy. It deals with the keywords tiny, discrete, and movement. So, to sum it up, the kinetic theory of matter states that a particle of matter consists of tiny, discrete particles, and these particles always move. They have energy, they randomly move. What is the difference between heating a particle and cooling a particle? Again, use logic, students. Imagine you heat water on the stove. What happens? Does the water boil or does it, form ice? Of course it boils, right? So when you heat something, it gains energy, which is why it reacts that way. So when you heat a substance, the particles gain kinetic energy and they move obviously faster. Notice how water is when it boils, you see those bubbles forming. So every time you heat something, the particles move faster. How does it work when you cool something? Exactly the opposite. When a substance is cooled, the particles they lose energy. The particles come together, they move slower. The kinetic energy decreases, therefore the particles move slower. It's all logic, students. Now, what is diffusion? Diffusion is simply the spreading of particles. Now, that may not make sense, but let me give you an example, students. Imagine you have a cup of coffee, okay, a cup of water, and now you want to add some coffee or some Milo into that water. What happens when you do this? As soon as you add that teaspoon of coffee or Milo, it automatically gets into the water. It mixes, blends in, and becomes one with the water. It becomes a new solution. This is what diffusion is. Excuse me. Now, in diffusion, you always see this term Brownian movement. I would not worry about it. There are some questions on paper 1. As soon as you see the word Brownian movement, just know that they're talking about diffusion. They're going to be options, this picture shows blah blah blah, Brownian movement. Immediately make the association. Brownian movement, diffusion. That's it. Now, this experiment is very important experiment, talks about diffusion. We're just going to go over it really quick. So, diffusion takes place in solids, liquids, and gases. Let's look at this example. For solids, you have a test tube as such, filled with a hot liquid gel, okay, and then at the bottom you add a crystal of potassium manganate. Now, just so you guys know, potassium manganate turns something into purple. So you leave this for a couple of days, what happens? The same thing with the liquid. So you have a test tube filled with water, you add a drop of potassium manganate. What happens? With a gas, now you have liquid bromine put in a jar, and then you add another beaker or another jar with air. What happens? So, as we expected, in the case of the solid, the purple potassium manganate, it fills up the gel. The gel now becomes purple. In the case of the liquid, same thing. The purple potassium manganate makes the water purple. Now, what about the last case for the gas? The bromine gas, which is brown. Now, you've got to remember this, students, for later on. Bromine gas is brown in color. The brown bromine gas mixes with the air, and the air becomes brown. What is the conclusion? As we said, diffusion occurs in solids, liquids, and gases, and in terms of speed. Now, again, this is something logical, okay? When it takes place in a solid, it's always slower. In a liquid, the liquid is always going to be in between. So, diffusion occurs at a medium pace in terms of liquids, and in terms of gases, it's always the fastest. Now, getting into the most important part of this chapter, the change in the state of matter. A state of matter is how atoms or molecules or ions are arranged. You have 3 states of matter: solid, liquid, and gas. So, the example I'm going to give you is water, ice, and steam. Perfect example, okay? So, water in its solid form is represented as, think about it, when you take water, you put it in the fridge, you get ice, right? And then water in the form of a liquid is water itself, and water in terms of a gas is, imagine you heat water, what happens? It forms steam. So we need to know the processes that take place when, say, ice becomes water, or when water becomes steam, and vice versa. So think about this, guys. When ice becomes water, it melts. When water becomes steam, it boils. The process is called boiling. Now, when you have steam and you want to get back water, it condenses. The process is called condensation. And obviously when you have water and you want to make ice, what do? You freeze it. Hence the process is called freezing. Now we've seen solid to liquid, liquid to gas, gas to liquid, and liquid to solid. What about solid to gas and gas to solid? Well, this process is called sublimation. Either ways, in both directions, students. So solid to gas is sublimation and gas to solid is sublimation. This process doesn't go through the liquid phase. Okay, very important to mention that. So let's go through the definitions of these. Obviously, melting is a process where a solid becomes a liquid. Here's the keywords: at a certain pressure and temperature. It has to take place at a certain pressure and temperature. Boiling, same thing. The keywords are the same. It's just the change in the phase. Boiling is a process where a liquid, let's look at that again, liquid becomes a gas is boiling. Okay, so process where liquid becomes vapor or gas at, again, certain pressure and temperature. For condensation, from a gas to a liquid. So condensation is a process where a gas becomes a liquid at a certain pressure and temperature. For freezing, okay, so water to ice, liquid to solid, freezing. So freezing is a process where a liquid becomes a solid, again at certain pressure and temperature. And the last one, sublimation. Remember, gas to solid or solid to gas. So the process where a solid or a gas becomes a gas or a solid at certain pressure and temperature. And the last thing you have to mention, without going through the liquid phase. Now, what is the difference between melting point and the word melting? The word point signifies temperature, students. So melting point is everything like melting with the word temperature. So the melting point is the temperature at which a solid becomes a liquid. And do we have a certain pressure and temperature? No more. We have the word constant pressure, because this is the temperature. So it's not a process that's taking place at a certain temperature. This is indeed the temperature. The same thing with boiling point. Boiling point, like boiling, is the temperature at which a liquid becomes a gas at a constant pressure. The last thing we're going to talk about in this subdivision is the differences between solid, a liquid, and a gas. Now students, I want you to be very logical in thinking about this. Okay, we're going to cover 4 topics: the arrangement of particles, the movement of particles, the attractive force between particles, and the energy content of particles. So let's start with a solid, how it looks. A solid is one where all the particles touch each other. They're close to each other. They can't move. They can only vibrate about their position. In the case of a liquid, not so close but not so far. Again, in the middle. The particles are somewhat close, they collide, but they can still move. In the case of a gas, the particles don't even touch each other. Far apart, they can move. Let's get into it. So, arrangement of particles for a solid: closely packed, closely arranged. In the case of a liquid, less closely packed. In the case of a gas, they are not closely packed at all. They are not in contact, they are far apart. Now, movement of particles. Do you think the particles in a solid can move? Obviously not. They are so close to each other that they can only vibrate about their position. In the case of a liquid, yeah, they can move, they have some space between each other, but they will collide against each other because they are somewhat close. In the case of gases, no, they are spread out, the particles can move freely, no problem. Attractive forces between particles, again, logic. Solids, they're so close to each other. Let's think of a magnet. When something attracts something, they come together, right? Exactly. So in the case of a solid, the attractive force is very strong because the particles are so close to each other. In the case of a liquid, moderately strong, not too good, not too weak, not too strong. In the case of a gas, the particles are so far apart. How will they attract each other? So the attractive forces between particles in a gas is very weak. The last thing, students, energy content. Now, think of an ice cube and think of steam. When you have an ice cube and you heat it, it becomes water. When you heat water, it becomes gas. Remember, when you heat water on a stove, what happens? It starts to form bubbles. The particles get excited. Obviously, that means it has high energy, right? Exactly, students. Energy in a solid is going to be the least. Energy in a liquid is going to be higher than a solid, and the energy in a gas is going to be the highest. It's all logic, students. This is the first part of the second chapter. I'm going to do in my next video. We're going to talk about naphthalene, just naphthalene, because naphthalene always comes out on SPM. And then the third part of the video is going to be all about your proton number, nucleon number, electronic configuration, isotopes. So stay tuned, guys, and keep watching my videos. Good luck.